Hey everyone, in this video we are going to discuss today's LeetCode contest, weekly contest 503. So let's dive into the problem set. The first problem is limit occurrences in sorted array. So you are given a sorted integer array nums and an integer k. Return an array such that each distinct element appears at most k times while preserving the relative order of the elements in nums. Note, if a distinct element appears at least k times, then it must appear exactly k times in the resulting array. Okay, so in this problem we need to remove the occurrences of elements whose frequency is more than k. Okay, and as given in the statement, the array is already sorted, so we will just solve it. So let's say we take a result vector, okay, and we will take a count variable. Let's iterate. If I equals to 0 or nums of I not equals to nums of I minus 1, in this case we will increase count by 1. In this case we will assign count equals to 1, otherwise we will increase the count by 1. Okay, and if count is less than or equals to k, in this case we are going to put into our result vector, and at the end just return the result vector. Num is the size of this array. Okay, so let's move to the next problem. Password strength. You are given a string password. The strength of the password is calculated based on the following rules. You are given 1 point for each distinct lowercase letter, 2 points for each distinct uppercase letter, 3 points for each distinct digit, 5 points for each distinct special character. Okay, special character is one of these. Each character contributes at most once, even if it appears multiple times. Return an integer denoting the strength of the password. Okay, so this is just the implementation as given in the problem description. So what we will do is let's create an unordered map of character comma points and call it points. So what points of point, let's, so here points of character C will represent the contribu contribution of character C in the final strength. Okay, let's add the contribution of each character. So we'll first add the contribution of letters. So for lowercase letters we get 1 point. For each of the uppercase letter we will get 2 points. For each of the digits, we will get 3 points, and for each of the special character, we get 5 points. There are 4 special characters. First one is exclamation, second one is at the rate, third one is hash, and the fourth one is dollar. And we get 5 points for each of the special character. Now let's calculate the strength. Strength equals to 0, iterate over this given string. Character C, password. Add the points into the strength corresponding to this character and mark this character's point equals to 0 because we have already added the contribution of this character into strength. Okay, because we are given that we need to consider the strength only at most once, right? For each character, each distinct character. At the end, return the strength. 11. Second one is also 11. Okay, so let's move to the third problem. In this problem, minimum operations to sort a permutation. So you are given an integer array nums of length n, where nums is a permutation of integers from 0 to n minus 1. You may perform only the following operations: reverse the entire array, rotate left by 1, means move the first element to the end of the array and rest elements to the left by 1 position. Return an integer denoting the minimum number of operations required to sort the array in increasing order. If it is not possible to sort the array using only the given operations, return -1. Okay, great. So let's try to solve it. Let's take this first test case. Okay. So let's apply first kind of operation, that is reverse to this, right? If we apply the first kind of operation to this, the array will become 1, 2, 0. This is just the reverse of this given array, right? So what is the so we want to see what is the correlation between the first kind of operations and the second kind of operations. Let's see, for the first kind of operation we'll just rotate this array, means not rotate, means reverse this array. Okay, and the second kind of operations, what they do is, so let's apply one operation. It will left shift this array by 1, so 2 1 0 will go to the last. Let's apply second kind of operations, second second operation on this array, so the array will be, this is 0. So if you apply again the second kind of operations, the array will become 102. If we apply the second kind of operation again, then the array will become 0 2 1, right? And again, if we will apply the second kind of operation, the array will become 2 1 0. So these operations, okay, 2 1 0, then 1 0 2, 0 2 1, again 2 1 0. So after three operations, you see that this array is again repeating. 0 2 1 is the original array we had, right? So we can see that after n operations of second kind, n operations of second kind, the array will again start repeating, right? And the order will remain same in the second kind of operation. By order, cyclic order will remain same. By cyclic order, what I mean is one is behind two, so one will always be behind two in the circular order, right? In this case also one is behind two, one is behind two, and in this case also if you see circularly, then one is always behind two, right? So second kind of operations doesn't change the cyclic order. And if we see the first kind of operation, here one was behind two, but here we see that one is two is behind one. So reverse, their order got also reversed here. Similarly for 0 2, 2 was behind 0, but here in this case we see 0 is behind 2. So if we see the first kind of operations, we see that their order also got reversed, right? So if we apply first kind of operations, that is reverse the array, their cyclic order also get reversed. So, and at the end of applying these operations, our goal is to sort the array, right? So how we can sort this? So one thing we can see is the integers will always remain adjacent to each other, right? Like if you, no matter what kind of operations you apply, either first kind of operation or second kind of operations, the integers always be in the adjacent, right? Like 1 and 2 will always be adjacent if you see cyclically, right? For both kind of operations. So from this, what we can tell is, we can tell that we will be only able to sort this array if this array can be divided into two parts, right? Let's say, and two parts from 0 up to n minus 1, right? So this part must be 0 1 2 3 4 5, and this part must be, let's 6 7 up to n minus 1. So one possibility, it can be one of the possibility. The another kind of possibility is we can divide this array into two parts, and the array will look like this: 0 1 2 3 4 5 6, and n, n minus 1, n minus 2, likewise up to 7. So there can only be two possibilities where applying the above two kind of operations can be sorted. After applying above kind of operations, these arrays can be sorted. Apart from these two possibilities, if there exists any other kind of array which does not follow this pattern, then the array cannot be sorted at all, right? So as we have only these two possibilities, let's solve this problem. You understand it, right? Why we can't sort an array if there is any other pattern apart from these two? Because let's say if there are two integers, 4, and then adjacent to this there is 6 and then 5, we cannot sort this array no matter how many operations you apply of the above kind. Why? Because 4 and 5 must be adjacent, then only we will be able to solve this, right? Because we see that in the above two operations, the adjacent integers will always remain adjacent after applying, no matter how many operations we apply, right? So as the two integers will always remain adjacent, and two integers in the sorted array, if there are two integers in the sorted array which are adjacent, then they must be one after another. Let's say 4, then there must be 5, right? So these are the only two possibilities we will have for the array to be sorted. So let's implement the solution. Let's say if n is less than 2, then we don't need to apply any operations, just return 0, right? Because there will be only one integer and that is always sorted. Now first find the index of 0, है ना? Because we are going to we are going to divide this array into two parts where we get the index 0. So first find the index of 0. Okay, now we have index of 0. Now we will see which kind of array is this, whether the array is of first kind or second kind. So let's check if the array is of first kind. For this, nums of I index plus 1 mod n, we will check if one is cyclically right side of 0. If one is cyclically right side of 0, this means the array is of first kind, right? In this case, we have two options. Either we left shift array this whole segment left shift by applying second kind of operations, then we will be able to sort this array, right? And another possibility is we can just reverse this array. Okay, after reversing, the array will look like this second type. Okay, now how we can sort this second type? So for sorting second type, we just need to apply second kind of operations for this complete segment such that this complete segment sits behind this. Okay, once this complete segment sits behind this segment, then our array will be sorted in decreasing order. Okay, now we can apply the first kind of operation, that is reverse the array. So both of these possibilities we will consider. So first possibility is first thing we need to check is that this array must be valid, that all of these integers must be contiguous. Let's say 1 should be after 0, 2 should be after 1, 3 should be after 2 cyclically, right? So let's check that this given array is valid for sorting. So for this, let's run a while loop. I j must be less than n, j plus plus I goes to I plus 1 mod n if nums of I not equals to j, just return 0. Just return minus 1 because we cannot sort this array if all the consecutive characters are not adjacent or not in cyclic order. Right. Once we found out that all the consecutive integers are in cyclic order, let's sort it. So for sorting, there are two possibilities. We will take minimum as we have discussed earlier. What we will do is we can just apply second kind of operations to this segment and put and make this segment sit behind this segment. So we at the end our array will be sorted. So how many number of operations do we need to apply on this segment so that all of these integers will be behind this segment, right? So so the number of operations we need to apply is idx plus 1. No, only idx, because let's say the index of 0 is, let's say, 1. In this case we are taking 0 based indexing, so let's say index of 0 is 1, then we only need to apply one operation because there will be only one element behind this. So, and another possibility is this one. We can either reverse this array, by applying first kind of operations, then the array will be converted to this, and for this the number of operations we need to apply is these many, the number of integers in the first segment plus 1 for reversing this array and 1 for initially reversing this array. So total number of operations are, how many integers are there in the first segment? The number of integers will be idx plus 1 and plus 1 for reversing and plus 1 for reversing in the starting. So total of 3 idx plus 3. Else for the second case, for this case, let's check the validity of the array. The same thing, similar thing. This time we should traverse in the backward order, right? Because 0, 1, 2 are in the reverse loop. So idx I equals to I minus 1 plus n mod n. Now our answer for this will be one of the possibilities. We either apply second kind of operations to this segment. It will need idx plus 1 operations plus one of the reverse operations. So total idx plus 2 operations are required for this case. And the another possibility is that we reverse this array. It will take one operation and then our problem will be converted to this, right? Our problem will be converted to this, and then we need how many operations? For above case we need only idx operations. Now one thing to notice here is if we reverse this, okay, so we need to reverse this, then it will be converted to this, and then okay, so one operation will also be required for reversing the array. Now one thing to notice is in the starting we are going to reverse this array, then index of 0 will be changed. So what is the new index? What is new index of 0 if we reverse it? It will be n minus 1 minus idx. And here replace idx with new index. Similar thing here, minus 1 and put new index here. Equals to 1. It's minus 1. It should be here. This is the second case. So I equals to idx. I equals to I minus 1 plus n mod n. So why are we having minus 1 here? 0, 1, 2. This is the second type of array. Nums of I not equals to 0. We also need, no, we don't need to apply mode here. No, we should apply. Because it can be negative. Okay, so if we run this loop, our index is 0. Okay, then negate 1, it will be minus 1. And minus 1. This this looks good to me actually. Cout I nums of I and also j. Why is it going in the bow loop in the first place? Let me check the value of idx. 0, that's fine. It should not go in the bow loop. Nums of idx plus 1, that will be 1. Mod, oh, what I have done. Okay, for the first sample test case, the answer is 2. For second, it's 2. For third, it's minus 1. Let's submit it. Okay, let's move to the third problem. The third problem is number of pairs after increment. You are given two integer arrays nums1 and nums2 and a 2D integer array queries. Each query of I is one of the following types: 1, x, y, and val. Add for this kind of query, add val to every element in nums2. Then second kind of queries, you are given two integers 2 comma total. Compute the number of pairs j comma k such that nums1 of j plus nums2 of j equals nums2 of k equals to total, and return an integer array answer for each kind of second type of query. Great. So let's see the constraints. First array has at most 5 elements, and second array has at most 10 order of 10 to the power 4 elements, and number of queries. What is the number of queries? Queries is also order of 10 to the power 4. So they are expecting a solution. Definitely they don't require n square or n into q solution. They want better. So for this kind of queries, for second kind of query, what do we need to check? This first is definitely an update query. Okay. And for second kind of query, we just need to check the total number of, for each integer in nums. We can definitely iterate nums1 because it has at most 5 elements. So for each element in nums1, we need to check the total minus nums1 of that integer, the count. So we need to check in nums2 the count of total minus nums1 of j, right? And j we will iterate from 0 to 5. So we need to implement a data structure which can give us fast the total count of integers in nums2 which are having a value equals to total minus nums1 of j. Okay, so this can be done with the square root decomposition. So what we can do is, one thing is, if the add query add value to every element, the first kind of query would have been a single element update query, then we could have solved this problem using merge sort tree algorithm, merge sort segment tree. But in this case, the query is on a range, right? And I don't think there exists a merge sort segment tree algorithm for this. So definitely we should move ahead with the square root decomposition algorithm. So for this case, what we will do is we will divide the given array. So let's say the indices 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So let's take an array of length 9, n equals to 9. We will divide into square root number of let's say size of we will divide this array into some segments whose size is square root of n. So for this case, square root of 9 3. So let's divide into the segments of 3 3 each, right? And now we will apply update queries easily. So for each update query, the number of iterations we will have to do is maximum of order of n, right? And for update, for query also we will have to iterate over whole of these segments, so it will also take root of n time. So how are we going to handle the update queries or the the second kind of query. Let's try to first implement, then I will explain it more clearly, because after implementation you will be able to better visualize it. So you understand this thing, right? We will divide this array into segments of size root n. So let's define n for the second. So constraint on value, that is we are going to add is value will be order of 10 to the power 5. They are also 10 to the power 5, so they can increase an integer range. So first let's create a nums array. Instead creates a nums array of long and add all of the elements of nums2 into this nums array. Size of nums array. Okay, now size of each segment we are going to divide. This will be square root of n. And so for each segment, what we are going to store is, for each segment we will take an unordered map, where we will take unordered map which will store int comma int, and here this first pair will store the integer, particular integer, uh, let's say ai. Okay, and this will store the frequency of this ai. Okay, so you understand me, right? For each segment we will take an unordered map, and let's call it count array. Okay, so it will store the frequency of each element in this segment. Let's take a vector to store all of the unordered maps for all of the segments. This will store, let's call it v for now, right? So what does v store is, v is of length m. M is the number of segments. So how many segments will be there? The total number of segments will be mm, n plus size minus 1 divided by size. This will be the total number of segments we will be having after dividing these into dividing the array into some segments of size square root of n. And this vector we will store the all of the unordered maps which contain the frequency of each element inside a segment. Got it? So first let's store the frequency for each segment v of, so in which segment does the ith index come? It will be there in I by size. This index will be in this segment, and add the frequency of this element. Okay, now iterate over the queries. First check if this is a first kind of query. In this case, what we are going to do is, First, extract out the other elements. Let's say x, y, z. X value of x will be q of 1, value of y will be q of 2, value of val equals to 3. Okay. Now check if index x and y both lie in the same segment, then we are going to just update all the values inside this segment. Also, one another thing, we will take a vector which will contain the values. Let's call it lazy. If you understand a simple concept of lazy, so what we are going to do is here is, let's say if there is an element which is, so if there is a range which is covering the complete segment, in this case we are not going to cover all of the elements of this segment. We are just going to update that particular value in the lazy segment, right? Because if a value is going to be added over a complete segment, so instead of updating each element value, we can just update the lazy segment, because we know if there is a value present in lazy, then lazy inside a segment, then we know that this value needs to be added into the complete segment. So in this case we will check if both lie in the same segment, then we can just update the complete segment. I equals to x, I less than equals to y. Okay, and here I by size of nums of I minus minus, because we are going to update this value, assign value size nums of I plus plus. Okay, otherwise if they are not in the same segment, then what we are going to do, then we are going to update the value of the first segment and the last segment, and in between all we are going to update the values of all of the elements in the first segment, right? Let's update it. I equals to x and I must be equals to x by, what does it now, tell me what does it mean? I by size equals to x by size. It means that we are only picking up, we are going to only update the values of elements in the segment which belongs to the segment of x, right? So let's update the values here. Okay, we updated the value corresponding to an index I which belongs to the same segment of index x. Now update all of the values of the elements which belong to the segment of index y. I equals to y divided by size into size. This is the starting index of the segment which belongs to y. I less than equals to y. Same thing here. Now, what about the segments in between the segment of x and y? We are not going to uh, update the value of each element in between these segments. We will just update the lazy value corresponding to each element, corresponding to each segment, right? Because all of the segments in between the segment of x and y will be completely covered by this range. So instead of updating each element, just update the lazy value corresponding to each segment. So I equals to x by size plus 1 I less than y by size I plus plus, and just to lazy of I plus equals to well. This is it. Now let's come to second kind of query and also take a answer vector for storing the answer to the second type of queries. Let's take a result here for now and iterate over nums1 and iterate over all of the segments. What value do we need? We need, for this particular segment, what value do we need? The value we need is total minus nums of 1, this one, and minus lazy of I, because this value is automatically added to this segment. Result also define this total equals to u of 1, and at the end just return the answer array. U is not defined. OQ. For first one answer is 2 1. For second one it is 2 6. For third one it is 1 0. Sample test cases looks fine, so let's submit it. Okay, great. So this was it for this video. Hope you liked the solutions. If you have any confusion or you want to ask anything related to this contest, do ask me in the comments. I will reply. Have a great day. Thank you.